Hey class, this is Mr. Weckeser. We're on 2.5 using linear models. And remember, linear means line, straight line, positive graph. There's also a negative graph, right? This is positive going up, negative going down. We have a zero graph, zero slope. And we also have undefined that goes straight up and down. And these are models, which means we're going to model linear. So here we go. Vocabulary first. Circle the set of data that you can model with a linear function. That means it goes up congruently every single time, like a step, right? Same amount every single time. First one goes up by 3 every time. So yes, you circle that. Birthdays of your classmates. It could be crazy, so that's not going to be correct. Because it all could be the same day, it could be different days. Amount of rain each day of the week, and that's going to be different every single week, every single day. So that is also not something you can model with a linear function that goes up with the exact same slope. Number 2, cross out the graphs that do not show a linear function. So ones that are not linear. And so this one's not straight, right? Because it's undefined. And undefined is not going to be part of the linear family, even though I just drew it above as a straight line. This right here it has zero slope, but it is part of this linear. This right here is a positive slope, so it is part of the linear family. This right here is an absolute value, and we're not going to do that. So that's going to be crossed off. That is not part of the linear family. All right, correlation, vocabulary builder. What does the word correlation mean? Correlation means to correspond, relate, correlation, coefficient. Lots of different things. So the biggest one just means it's related to or corresponding. It's in the same group. Say a correlation is a relationship between two sets of data points. How are they related? And usually they're related by a factor, right? Kind of like your cousins and you're related by an aunt or an uncle. So using your vocabulary, use a correlation that most closely represents each situation below. So most closely is the key word. Write the letter of your choice in a box, using each letter once. So the age of a used car and the car's value, is that going to go up or down? Well, the longer the car is used, the more it's going to depreciate in value. So we're looking for one that goes down in value. And that's going to be B right here, because it's going down. So some go down drastically, as some don't go as fast. But it's going to be B. The color of your hair and the weather in Venezuela. Is there any correlation between those two things? No, that's a C. No correlation here at all. And the number of hours you worked an after-school job and the amount of your paycheck. Right? The more hours you worked, here's the hours, and here's your pay. They both go up at the same time. So that's pretty sweet. That's a good one for you to remember the rest of your life. Right? Pretty much, the more you work, the harder you work, the more you will get paid. So let's go down to the next page. Using a scatter plot, and you've done this since like 3rd grade, maybe 2nd or 1st. The table shows number of hours students spent online the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation? So this is number of hours online, right? So the more they were online, this is not studying online. This is like playing games or on social media, right? So the more you're online, the lower your score is. So the more you're online, the lower your score. This guy was online 0, scored 100, 0, 94. Right? It's not always going to be a positive correlation. Sometimes it goes up and down, right? Because you see a 2 here, it's low. You see a 3, it's a little higher. So plot the data pairs on the coordinate graph. So let's go and do that. Sorry about that, guys. Here we go. Let's graph all the data points first. We have those 0 100s first. We have a 0 94 right here. We have a 1 with 98. We have a 1 with an 88. We have a 1.5 with a 92. We have a 1.75 with an 89. A little higher maybe up here. We have a 2 with a 75. We have a 3 with a 78. We have a 4 with a 72. We have a 4.5 with a 57. Ooh, that's not a good grade at all, folks. You don't want to be looking for that grade. You have a 5 with a 60. So you have them all done. The data pairs are tightly clustered around a line. Is that true or false? True. As an online time increases, the test scores increase. No, it's the opposite. So you can make it called a line of best fit if you wanted to. And you could do something like this. And that's called your line of best fit. And this is the hours online. I forgot to do this. And here is your test scores. I'm writing sideways. There you go, boys and girls. There is a strong negative correlation between the hours online and your test scores. So don't be online if you want to get good test scores. Turn your phones off and study. Write in the equation of the trend line. Here's another trend line. No problem, too. The table shows the median home prices in California. So medium is the middle. What is the equation for a trend line that models the relationship between the time and home prices? Graph the data on the coordinate plane at the right. So here we go. Let's graph all the data. In 1940, it was 36,700. And this is tricky here because down here we need to write the X and Y axis. Let's write this first. Here's the price. And here's the years. And this is the tricky one. Since 1940. So the trick is you need to look up here. And I don't know. Here it is. Use 0 to represent 1940. So this is really 40, 50, 60, 1970, 1980, 1990, year 2000. Okay? So let's not get confused with that. 1940 is going to be 36,700. 1950, 5790. 1960, 74.4. 1970, 88.7. 1980, big boom there, 167. That's a huge boom. 1990 is 249, another big boom. Boom. Look at how much houses increased there. And then the year after, right here, is 211, so it actually went down a little bit. So, and it probably had even further down the next decade. That'd be the housing crisis. So let's try to make a line of best fit here. You'd have to just somehow get all the data in there if you can. That's probably the best line of best fit. Point 1. Choose 2 data points in the graph that shows the trend line. About half of the points should be above the line, half should be below it. Point 1, we're going to use, they say use about 10 and 57,900. I use a semicolon here. So here's the first trend line data, about. The next one is 60 and 211, 500. And they're very close. Now here's a 60 right here. And that's the trend line. Draw the trend line, and we did that. The trend line is just drawing a line, a best fit. There you go. Now write the equation for the line of point slope form. So we're going to use 2 of those points, which we wrote down right there. 211, 500 minus 57, 900 equals m, which is going to be your slope, 60 minus 10. So you get, if you add this together, you get 153,600 equals 50m. And then you divide by 50, you get 3,072 equals m. So y minus, here's your big thing here, because now we have the slope, 211. This is the tricky part. You got to find the slope and then do the whole thing again in point slope form and then slope intercept form. 72 x minus 60. So this is your slope, goes up in this right there. So finding the line of best fit, problem 3. Sorry about that. The table lists the cost of 2% milk. Using a table to find the equation of the line of best fit. Base your linear model, right, on how much you would expect to pay for a gallon of 2% milk in 2025. And this is actually crazy because milk right now is less than this. So this doesn't always work out. It works out not always the same. So what are we going to do here? Let's look down here. How much would you expect? Make a guess here, right? But you can make an equation, you can subtract, right, and make a line and do all the work. But we'll talk about that in a second, okay? Let's do number 13. Use the information in the table in the stat screen below to complete each sentence. Blank is 0 year, 1998. And 2025 is year 27. So these are just the stats from right here. Then use the line reg screen below to write an equation for the line of best fit. Round the nearest hundredth if necessary. So we have 0.09 x plus 2.54. Right? So here it is right here. So I know this is crazy stuff, just bear with me. So now we're going to find the line of best fit for exercise 13 and 14, how much you pay for year in 2025. So we're going to do y equals 0.0927. We got the 27 from here, that's year 27 after 1998, plus 2.54 per gallon. You're going to get, if you solve all of that, you get y equals $4.97. That's pretty outlandish. Milk actually has been controlled by the government, so it's not that expensive right now. So you guys are lucky. Your parents actually are. I would expect to pay how much for a gallon of milk? And that's $4.97. That's really only in like New York or Hawaii or a high-priced area like that. So let's go to the next page. Here it is, lesson check. Do you understand? So we did all of 2.5. This is lesson check. Positive correlations and negative correlations. You're just going to put these ideas right here in one of these sequences. And if you want to make it easier for yourself, because there's a lot of writing involved here, you can label this 1, 2, 3, 4, 5, and 6. Then put the numbers in the right area. So for the first one, as the value of the variable increases or other decreases, you're going to put that right here, number 1. And so that's a negative correlation. So you're going to do all of that, and then you're going to do the rest of the lesson check, and you're going to circle one of these guys and show me the answers. That's it, and do the homework. That's 2.5. Have a great day, guys.